Hi, I'm Amar, and in this video I will explain wavefronts and the Doppler effect.
Wavefronts are any line on a wave where there are joining points that are in phase on a wave. These are usually crests or troughs, but they can be any repeating points that have been affected by the wave in the same way at a certain time. The Doppler effect is the relative change in frequency and wavelength of a wave. The Doppler effect occurs when the source of a wave and the observer move towards or away from each other. This is because from here, as each wavefront is traveling, the next wavefront has already cut up a bit because of the movement of the source towards the direction of the previous wavefront. The opposite happens at the other end of the source. After a wavefront has been emitted from the source, the next wave will be emitted further away from where the first wavefront was emitted. But this wave is the same speed as the first wave, so it takes longer to reach the position in which the first wave was. This makes it seem as though to an observer that the wave has a longer wavelength and lower frequency.
Mathematically, the observed frequency can be calculated using these formulas. If the source is moving, then you would use this formula. F represents the actual frequency of the sound wave. F prime is the observed frequency by the observer. V is the speed of the sound wave. US is the speed of the source. If the source is approaching the observer, then the apparent frequency f prime is greater, which means we use a negative sign. On the other hand, if the source is moving away from the observer, then the apparent frequency of f prime is lower, which means we use a positive sign. But if the observer is moving, then you would use this formula. If the observer is approaching the source, then the apparent frequency of f prime is greater, which means we use a positive sign. On the other hand, if the observer is approaching the source, then f prime is lower. This means we use a negative sign. Be careful when applying a positive or negative sign to the speed of the source. Just remember that if the source is moving away from you, it will have a lower frequency and higher wavelength. If the source is moving towards you, it has a higher frequency and lower wavelength. That's why you can always tell if an ambulance is moving towards you or away from you. If the siren has a high pitch, then it's moving towards you, but if it has a low pitch, then it's moving away. This doesn't just happen with sound though, it also happens with other waves like light. If a source of light is moving further away from you, it will seem to have a lower frequency or higher wavelength. This creates an effect called redshift. This is the change in color resulting from the movement of an object away or towards the observer. We can use this to determine if stars are moving away or towards us. Because we know the chemical makeup of the star, we know the frequency of light it should emit. If an object is redder, then it's moving away from us, and vice versa. If an object is moving towards you, then it would be bluer. This is because the lower wavelength light is the bluer it appears, and the higher wavelength the redder. This has only been a relatively recent discovery though, as a change in wavelength is so small that its effects were only discovered in 1929 by Edwin Hubble. And the reason it's redshift and not blueshift is because most of the stars we've observed have appeared redder than they're supposed to. This, at the time, helped support the theory of the Big Bang.